Chapter 15.5 Compound Interest. When interest is added to the principal at irregular intervals, each successive interest payment is calculating based on the new amount. So once you've found the interest and added it to your principal, that becomes your new principal. Unlike in simple interest, the principal stays the same and it's constantly off the same principal. However, when you do the time, if the interest is calculated annually, divide the rate by 1. If it's 6 monthly, divide it by 2, and so forth. The formula we're going to use for simple compound interest is this one just here. Okay, so A equals P, and that's multiplied by 1 plus your rate to the power of N. Notice with compound interest, now N is your time. This could be your years, instead of using T. Okay, A is future amount, P is still principal, R is still the interest rate, and N is years. However, with R, you might have 5%, for example. What you need to do is you're going to divide it by 100. And that's going to create a decimal looking like that. This is what your R is going to be now, not the 5%. To work out your compound interest, you're going to take away your principal away from your A, which is your future amount. Okay, work example 8. William has $14,000 to invest. He invests that money at 9% per annum for 5 years with interest compounded annually, and so forth. Question A is asking you to use the compound formula to calculate the amount to which this investment will grow, and B, the compound interest, or calculate the compound interest earned on the investment. So I'm just going to break it into two parts. First of all, mark out what's important. So we know P equals 14,000. We know your R equals 9%. We're going to make that into its decimal, which is 0.09. And then N is going to be 5 years. In this one, because it's 5 years, it's going annually, just keep it as 5 years. Substitute what we know. So we've got A equals 14,000, and you've got 1 plus your R, which is 0.09, and it's going to be compounded by 5. Separated a bit, 14,000, got to fill in those brackets, multiplied by 1.09, and that's going to be to the power of 5. And then we work out so the answer is going to be 21,540, and it's going to have 74 cents. Okay, so that's going to be your total in the end after 5 years. Now, question B is actually asking you to find out the difference. So we're going to grab this answer and we're going to bring it up. Now remember, we're using A take away P. So this is A, so $21,540.74, and you're going to minus that 14,000. So in the end, what you're going to get for CI, which is compound interest, is 7,540.74 cents. So part B is that. Alright, so another work example. Maurice has 15,000 to invest. He invests the money at 6% per annum for 5 years, and it's compounding annually. So question A, use the formula that we've given for compound interest to calculate the amount to which this investment will grow. Okay, so first of all, write down the important information. So P equals 15,000. R, we know it's 6%, so divide it by 100, and you get 0.06. And N is 5 years, so it's 5. Substitute PR and N into your formula, and we get A equals 15,000 bracket 1 plus 0.06, and you're going to put that to the power of 5. Expand the brackets. Now you can jump straight to this if you like, but I'll do it anyway. Multiplied by 1.06 to the power of 5. And then you get 20,073.38. So this is how much your investment has grown. Part B, calculate the compound interest earned on the investment. So again, like we did before, we've got 20,073.38, and you can take away that 15,000. And basically your compound interest will work out to be $5,073.38. So that's how much interest you've earned over 5 years. Alright, work example 9 is slightly different, okay, and this is where you need to start focusing. So it says calculate the future value of an investment of $4,000 at 6% per annum for 2 years. Now that's the same as the previous question, but here it says with interest compounded quarterly. Now we know there's 4 quarters in a year, so that's very important. Alright, so we're going to use the same formula. We're going to have A equals P times 1 plus your rate to the power of N. Now the difference on this one, we need to use this word quarterly. What that means is we're going to divide our rate by 4. And we're going to times our N by 4. Okay, so we'll put that in. So we've got A equals, now of course you've written out P equals 4,000, R equals 6, and N equals 2. So R we're going to divide by 6, but we're going to put that 6% into a decimal obviously, and then divide the decimal by 4. So we've got 4,000 is your P, 1 plus, and here we're going to have 0.06 as the decimal divided by 4, and here we're going to have 4 times 2. It technically should be around the other way, 2 times 4. Alright, so from here, expand our brackets. We've got 4,000. Now 1 plus, if you look at this, 6 divided by 4 is 1.5, so we're actually going to have 0.015. Okay, and this is to the power of 8. When you put that in the calculator, so it's obviously 1.015 to the power of 8. When you put this in the calculator, you're going to have A equals 4,505.97. Oops, 7. That's a good 7. Alright, so the future value for our 4,000 investment is this one here. Okay, we've got another work example 9. So calculate the future value of an investment of 8,000 at 12% for 2 years. So instead of annually or quarterly, we've got invested monthly. Yep, 12 months. Okay, so nice and important to know. Then from here, what we're going to do is we've got our important information. P equals 8,000. We're going to have our R equals 12, but we're going to put that into its decimal, 0.12. Now, because we're doing it monthly, we're going to divide that by 12. So that actually equals 0.01. And our N is 2 years, but we're going to multiply that by the months, so 12. So N is actually going to be 24. Substitute these bits of information in. So we have A equals 8,000. We're going to have the 1 plus the 0.01 from here. And that's going to be to the power of 24, which is from there. From here, we put that into the calculator, and you're going to have $10,157.88. And that is your future value.